So this is homework 13, which is adding and subtracting fractions. I've got a few questions here for us to practice on, and the first question is 4 over 7 plus 3 over 14. And the key here is to make sure that the denominators on both fractions are the same. If they aren't the same, we can't add them together. So the first step is always to make sure that the bottom numbers are the same. They're called denominators. And how I would make 7 the same as 14 would be to double the denominator here. But if I double the denominator, I'm going to have to double the numerator as well. So what I'm going to do is change 4 over 7. So 4 over 7 is the same as, I'm going to make it twice as big so I can make it the same as 14. Is 8 over 14. So what I'm going to do now is replace 4 over 7 with 8 over 14. So 8 over 14 plus 3 over 14. So now the bottom numbers are the same, because all I did was double the denominator, which was 7, to 14, and double the numerator to 8. So 8 over 14 plus 3 over 14 is 11 over 14. And that's the final answer. I've just added the top numbers together to get 11, and the bottom numbers stayed the same. Next question is 8 over 15 minus 2 over 5. Now, what I would do here, we've got to make the bottom numbers the same, the denominator is the same. So I'm going to make 5 into 15. I'm going to triple the denominator of this fraction to make it into 15, but that means I have to triple the numerator as well. So 2 over 5 is the same as, I'm actually making it 3 times larger, times in it by 3, is 6 over 15. So I've got 8 over 15, which hasn't actually changed yet, we haven't had to change it, minus 6 over 15. 2 over 5 is the same as 6 over 15. So all I've done is just used an equivalent fraction. Now, if I'm going to subtract, I subtract the top numbers, so that's 8 take away 6, which is 2, and then the bottom number still stays the same, which is 15. So 2 over 15. Right, the next one's a little bit trickier, because you'll see that I can't change either of the denominators to be the same as the other denominator. So I'm going to have to multiply them both. So what I'm going to do now is think of the smallest number that is a multiple of both of these numbers. I'm going to look for the lowest common multiple of 4 and 6. If I multiply 4 by 3, I get 12. If I double 6, I get 12 as well. So my bottom number is going to be 12. So the lowest common multiple of 4 and 6 is 12. So I'm going to make both denominators 12. To do that, I have to multiply this by 3. So I've got 3 times 3 is 9 over 12. So that's my first fraction. And then my second fraction, 5 over 6. To make 6 the same as 12, I'm going to have to multiply by 2. So 5 times 2 is 10, 6 times 2 is 12. So I've got 10 over 12. So this is the fraction we've been given. 9 over 12 plus 10 over 12. So we do the same as before now. Bottom numbers are the same. So we do the same as before, which is add in the top numbers, which is 19, over, and the 12 stays the same. 12. Right, last question now. 2 over 7 minus 1 over 8. Now, to think of the lowest common multiple of 7 and 8, I've got to think of the smallest number that is in both of their times tables. What I would do, the lowest common multiple is 56. Nope, it's not. Yeah, 56. 2 over 7. If I multiply this by 8, so if I multiply 7 by 8, I get 56. And if I multiply 8 by 7, I get 56. So I'm going to get the same numbers on the bottom both times. So I'm going to get 2 times 8 is 16. 7 times 8 is 56. So the new fraction for 2 over 7, the equivalent fraction is 16 over 56. And then I've got to make an equivalent fraction for 1 over 8. And I'm going to have to times this fraction by 7. Or the numerator and the denominator by 7. So 1 times 7 is 7. 8 times 7 is 56. So the equivalent fraction for 1 over 8 is 7 over 56. So I'm going to replace this one here with 7 over 56. And now if I'm subtracting, 16 take away 7 is 9, and the 56 stays the same. The denominator stays the same, because the denominator is the same. So the answer was 9 over 56.